Alright, 45 is what we're going to look at today. So let's all open, please, to page 148. And we are looking at volume. Alright? So volume, we said area. Let's review area real quick because they're going to be related. Alright, so Porsche told us the formula for area, length times width, or base times height. Nope, that's good. But we need to determine what area is. Right? If I just drew this, Devon, can you tell me the area of a straight line? No. What could you tell me about a straight line?
What?
Devon, what could you tell me about a straight line? You couldn't tell me area, but you could tell me the length, Porsche. The length. Okay? The length only has one dimension, right? One dimension. So for me to Porsche, that distance is a straight line. We just have a length. It's only one dimension. I only have to move forward to get to Porsche, right? Alright, if I include a length and a width, like Porsche told me, I can fill it in, right? So I have a length now. We could also call that a base, and a width, which we could also call what, Jamaica? Come here, please. What else do we call width? We call it length or base. We call it width or... Look at it. If this is the base, what is that? This is length or base. We say this is width or
Height.
height. Good. Alright, so width or height. So you have two different dimensions, right? So two length. So this, when we multiply length times width or base times height, we get area, which is two dimensions. So now, okay, I'm going to wear shoes that don't stink today so you can see. We just have one shoe, right? Like 1 foot. That's one length, right? A length, 1 foot, like a length. If I take my shoe and I do 2 length times width, right? And I could close it in with 2 more shoes that were the same height as mine, right? I would have an area. You agree? Yes, no? Okay, area, 2. Now, I'm going to do some gymnastics. If I include a third foot, right? Anyone have slip-on shoes? Nobody does. Oh, man. Alright, so, I'll use my bottle. We're going to pretend this is a shoe today, okay? So I have 1 shoe, 2 shoes. My area, like we just said, right? Now what if I add a third dimension to it? Okay? So now it goes up and down, side to side. I've got a length and a width. But now I add a dimension either towards you or away from you. And if I were able to close that in, that would be like a box, a 3-dimensional box. Right? It comes towards you or away from you. It moves sides to side and it moves up and down. Okay? So the way that I like to say is if we go area, alright, I move sideways and I move forward. Right? Area, 2 dimensions. For volume, I would have to move sideways, forward, and up and down. Okay, so I've got all 3 dimensions that we can cover in space. Think about a 3-dimensional movie, right? You have the big screen. That screen is projected. It's got a length and a width of that screen, right? And a 3D movie starts to come at you. So it adds a depth to it. Does that make sense? Okay? So, when we draw a picture, of 3D, we give it the box, like we did for length and width, and then we can add that 3rd dimension to it. And I've got some practice drawing cubes, so if it takes you guys a little bit longer, that's okay. There's a cube, so we have our length. Let's call the same size. We have our length, we have our width, and now we have our depth here. Okay? So this is our depth, or we have length, width, and height, okay? We can use all sorts of different words to describe. I need eyes up here, please. All eyes up here. Pushing. Alright, so we're going to have different words. Length, width, height. Okay? Base height times a third dimension. So we're going to have to give that a different name. So it's not going to matter necessarily what kind of names you give it, as long as you understand 3, so length times width times height, gets you volume, and that is 3 dimensions. Okay? So 3 dimensions. So if we can keep in mind how many dimensions it has, that's also going to help you as you're labeling your answer. Okay? So Jamaica, we talked about cubes this morning as we were doing like the cube root, or 4 to the third, 4 cubed. Now we have that cube in a different context. This, because it has 1, 2, 3 dimensions, when I write the units for volume, I'm going to have, let's use centimeters. If this was 1 centimeter, and 1 centimeter, and 1 centimeter, I have 1 times 1 times 1. The numbers are easy, we just multiply those 3 together. We also have to multiply the units together. So we would have 1, because 1 times 1 times 1 is 1, centimeter cubed. That's how many dimensions we have. So the dimension number is kind of what you can know is going to go up in that little exponent box next to your units. Okay? So for area, same thing. If we had 1 centimeter and 1 centimeter, when we multiplied 1 centimeter by 1 centimeter, for area, we got centimeters, 2 dimensions, so centimeters squared. This is 1 centimeter squared. Up here, length is 1 centimeter. It's not multiplied by anything, 1 dimension, so you've got cm. We know anytime you don't write it, it's invisible, right? Make sense? So that's how we're going to know what unit to give it. Centimeters cubed, or meters cubed, or foot cubed. Whatever the type of length measurement that they give you in the problem, you know if you calculate volume, you're going to need a little 3 up next to your units. Okay? So, just a little introduction. So if you look at your book, in that picture, they've drawn a picture similar to my picture, shaded it in a bit, and showed you 1 centimeter by 1 centimeter by 1 centimeter. Okay? It goes up and down, side to side, and forward and backward. Okay? Up, down, forward, backward. Okay? So, we can multiply them together. So what you're doing, kind of picture little sugar cubes. You remember, you guys ever seen those little white sugar cubes?
Yeah.
Alright, so if you take those little sugar cubes, that is one of these, right? It's got 3 dimensions. So that little sugar cube has a volume. It's a cube. That little 3 there means cubed. Okay? So keep in mind, that little 3 means cubed. So when we talk about cubes, like a Rubik's cube or a nice cube, right? They all have that 3-dimensional kind of boxy shape, like a cardboard box. Okay? So if we break it down, and we took that centimeter cubed, I'm going to erase this step to give us a little more space, and we drew him, we make him a little bit bigger. Okay? And I'll make him go back pretty far. Alright, so I've got my new big, huge cube. Okay, eyes up here, please, Tamika. About put that away, please. Alright, so now I tell you that this length right here is 3 centimeters. So we know that that means I can kind of break it down into 1, 2, 3 centimeters, right? Alright, and I say this length is also 3 centimeters. 1, 2, 3 centimeters. And I tell you this length back here is also 3 centimeters. 1, 2, 3. Not worried about that right now. Alright, so 3 centimeters. So now, instead of just 1 times 1 times 1, if we actually figure out how many cubic centimeters we've got, one of the ways that we can look at that is literally to break this box down into all of its little sugar cubes. So it takes 9 to make up the area of the front, right? 9 cubes. And then there are 3 layers deep. So we've got this one right here. We've got this box right here. I didn't draw this super well, but you can see it here, right? So this box, taken care of. 2, there are 9, right? In the second layer, 1, 2, 3, there are 9 more cubes. In the third layer, there are 9 more cubes. So 3 times 3 got us, 3 times 3 got us 9. And there's 1, 2, 3 layers of 9. 3 times 3 times 3 gets us 27. So there are 27 cubic centimeters when you have a cube like that. 3 times 3, think about the base has 9, and there are 3 levels deep of that cube. Okay, so 3 times 3 times 3. So if you think about a cube, that's 3 centimeters by 3 centimeters by 3 centimeters. We've got 27 cubic centimeters. Is that clear to everybody? Are there any questions on that? Make sense? Yes? All right, so we've got our formula. Another way, you guys are used to length times width times height. One of the things that I want you to do, this is going to be hard, I need your eyes on 149, please. Okay, one of the things I'm going to want you to do, we did this to figure out dimensions, but we said area was length times width, right? Okay? So what I want you to do in your heads now is to start associating volume. We're going to give it a sort of a new formula. Rather than think length times width times height, because that only works for a regular rectangular solid, like we did here, think about this as the area of the base times the height. So the new formula we want to give to volume is the area of the base times the height. Okay? This, right here, you need to tuck away your brains. Because as we start to add in some triangular stuff, or circles, or semicircles, which we'll get to later on, you're going to have to know volume isn't just length times width times height. We need to associate the area of the base times the height. So like we did here, we found the area of the base, 9, 3 times 3. So we multiplied it by the height, 3. That was pretty easy. Okay? Eyes up here, please, for shame. Okay, so we got 27 by taking the area of the base, 9, times the height, 3. Okay? So, put this formula in your head, and let's cross off our length times width times height formula. Okay? Still works, but keep in mind, we need to use the area of the base times the height. And we'll review that a good bit. So, let's look at our first example. Okay, they're often going to give you a picture of the base. So in this picture, it tells you the base is shown. The base is 2 by 6. So Damon, what's going to be the area of the base if it's 2 by 6? 12. 12, it tells us that it's measured in centimeters. So 12 centimeters squared. Good. So 12 centimeters squared. And it tells us that it is 4 centimeters tall. So Damon, what am I going to need to do with 4 centimeters now to figure out my volume? I have my rectangle. It tells me in my information that this is 2 by 6 and it's 4 tall, right? Kind of tip it over on its side. So Damon, what's going to be the total volume of that rectangular solid? 48 what? 48 centimeters to the third, also known as cubed. Okay, so let's start using that word cubed. 48 centimeters cubed. Good. All right, so the example 45.2 is what I was talking about, why we need the area of the base instead of just length times width. Because if we look at that shape, we have an irregular looking shape here. Okay, we have an irregular looking shape. If you look at the picture, it looks kind of like this. Alright, and that's not a rectangle. So this isn't going to be super difficult, but it's not going to be as easy as length times width times height. Cross that one off, and we need to go over here. So we know 4, 6, and 10. Okay? So, how, Jamaica, am I going to break down this irregular shape to figure out the area of my base? Eyes up here, please. Put your person down, please. Eyes up here. Tamika, eyes up here. How am I going to figure out the area of my base here in order to figure out my volume? What am I going to start with? This is my shape right here. How am I going to figure out the area of my base? Help me out. Well, how do we start? What do you see there? 10, 6, and 4 on an irregular shape, right? What two shapes do you see put together here? Well, how can we break this irregular shape up? We divided it up like we practiced doing with our area. A square? A square? Be careful with our words. Okay, I don't see a square. So we might call that what instead? It's not a square, it's a rectangle. Alright, so we've got a rectangle and a triangle. So what are the dimensions of my rectangle, Tamika?
10, 6.
Of my rectangle? How wide is my rectangle and how long is my rectangle? You need to figure that out. Look at just the rectangle.
6.
Okay? 6 and
4.
4. So what's the area of just my rectangle? 24 what? Tells me that units are in feet. Okay, so if it's an area, it's 24. What do we say with area? Still up here. How many dimensions does area have? No, not oh my gosh. Right, how many dimensions does area have? How many dimensions, Portia? This is Shamika's, not yours. Shamika, how many dimensions does area have? 2. How do you know? She did. Goes, how do I figure out area? Right. And it says, if we said base times height, that means it's got 2 dimensions, right? An up and a down, and a side to side. So it's going to be feet what?
Square.
Feet squared. Well, 3, 2, 1, 7, 6, 8 what? If it's 2 dimensions, it's feet
Square.
squared. Which is it, Tamika? We can't say both. Squared, not cubed. Cubed is the little 3. That's when we have 3 dimensions. And we said with area, we only have 2 dimensions. Okay, so Destiny, how am I going to figure out what's left of my irregular shape? Okay, so 1/2 base times height. What's my base? 6. Good. So here, she knew that from here to here was 4. So she was figuring out from here to here. We know the total is 10. This guy's 6. We're told he's 6. So 6 times 6 is, or do 6 times a half? What's 6 times a half? 3 times 6? 18. Beautiful. 18 what? Jamaica. 18 what, Destiny? Feet squared. So Damon, what is my total area of my base? Portia. Eyes up here, please. What's the total area of my base here, Damon? If I know that the rectangle is 24 feet squared, and I know that my triangle is 18 feet squared, what's the total area of my base? I'm figuring out the area of my base here. So what's my total area of my base here? 42. Beautiful. 42 what? Feet squared. All right, so Portia, we have a base of 42 feet squared. Eyes up here, please. We have a base of 42 feet squared. How tall does it tell us it is in our example? Look at it, please. Example 45.2. How tall is our shape? This is the base. How tall is it? 6 what? 2 what?
6, 4.
You have 6, 4, and 10. Those are all on the base. I need to
Which
know how
one is
tall.
45.2
45.2 is the one we're working on.
So the 96.
6 what? 6 feet. Good. So I have a base of 42 feet squared. So let's plug this back in over here to my volume formula. My area was 42 feet squared. My height, you just told me, was what again, Portia? How many? How many? How your height. Think about
Six.
something. 6 what?
I did
You did just say 6 feet. Good. Now what am I going to do with those two numbers to figure out my volume, Portia? Multiply. When you multiply them together, what do you get? You can look at your book. I'll even let you do that. I know you know how to multiply pretty easily.
30, 60,
Huh?
6,
42 times 6 is 60.
42. Where you get 42
That's what
from?
we figured out. John told me the area of my base was 42
Okay, hold
feet
on.
squared. Portia, look at the book. Portia, look at the book.
252.
252. So my volume is 252. What though?
Feet 3.
Feet to the third. Feet cubed. Good. All right, so you guys have a couple practice problems to do for that. You have A, B, and C. And B and C have irregular bases. So B and C, we're going to need to do similarly to how we just did the second practice problem. The first one, hopefully, will be pretty straightforward because it's a regular shape. Okay?